Good day, class. Today we are going to be looking at structure of the atom, which is also known as atomic structure. Introduction. As a way of introduction, we can see that an atom is present at the most basic level in everything we see around us. There is nothing around us that does not contain atoms, because atoms are the simplest components of living organism. But living or non-living organisms have atoms in them, because atom is the smallest indivisible particle of an element. As we all know, matter makes up every non-living thing around us, such as chairs, tables, and all whatnot. But the building blocks of matter are atoms. And so the composition of everything, living or non-living, is atoms. Atom, as the name implies, is a Greek word which means indivisible. The Greeks believed that matter can be broken down into very small indivisible particles called atoms. Greek philosophers such as Democritus, and John Dalton put forward the concept of the atom. Democritus explained the nature of matter. He proposed that matter makes up all substances. He stated that atoms are constantly moving. They are invisible, they are indivisible minuscule particles that are different in shape, size, and temperature, and that we cannot destroy atoms. What this is saying is that atoms are always moving. They are constantly moving around, and they are of different size, shape, and temperature at every given time, and that atoms cannot be destroyed. In the later part of 1808, John Dalton proposed the atomic theory. He explained the law of chemical combination. By the end of the 18th and the early 20th centuries, many scientists developed and proposed several concepts on atom, one of whom is J.J. Thomson, Goldstein, Rutherford, and Bohr, among others. So, the atom is the smallest unit of matter. It is the positively charged, it consists of a positively charged center, termed as nucleus. Also, negatively charged electrons around the central nucleus. What this is saying is that an atom contains a positively charged center. The center of the atom is positively charged, and then it also contains the negatively charged electrons, and the electrons are constantly revolving around the nucleus. Even though an atom is the smallest unit of matter, it contains all the chemical properties of an element. For example, silver atoms and a few other constituents make up a silver spoon. The tiny subatomic particles that compose a silver atom define the properties of the silver atom. Atoms are further arranged and organized to form larger structures known as molecules. Atoms and molecules adhere to the general chemistry and physics rule, even when they are part of the living human body. We can now study the structure of atoms to further understand how the atoms react, behave, and interact. So, structure of the atom. The structure of atom consists of two parts, an atomic nucleus and the extra nucleus part. The atomic nucleus is the center, which contains proton and neutron. Contains proton, which is positively charged, and then neutron, which is neutral. And then the extra nucleus part consists of the revolving electron. You can see this is the diagram of an atom consisting of the center and different orbits revolving around the center nucleus. So you can see from the diagram that we have proton, we have neutron at the nucleus. That's the center. You can see the center, which contains the proton and the neutron. Proton is positively charged, while the neutron is neutral. Is neutral. And then we have the electron. You can see the electron. They are in different orbits revolving around the nucleus, and that is what you see now is what we refer to as atomic structure or structure of the atom. This is basically how an atom looks like. The tiny atomic nucleus is the center of an atom. It constitutes positively charged particles, protons, and uncharged particles, neutrons. On the other hand, the extra nucleus part is a much larger region. It consists of a cloud of negatively charged particles called electrons. And electrons revolve around the nucleus, just like I have earlier said. Generally, all atoms except hydrogen consist of these three subatomic particles. Hydrogen is an exception to all atoms, as it contains just one proton and one electron, but lacks neutrons. So we can see, just like in every general rule, we always have an exception. We have an exception to this, where hydrogen is an exception to atoms because it has only one electron and one proton, and the hydrogen doesn't have neutrons, so it's an exception to what we are talking about. The atomic nucleus is the structure of atom. In the structure of atom consists of a fixed number of protons. Also, the proton attracts some number of electrons, thereby making an atom electrically neutral. The addition or removal of electrons from an atom results in the formation of what we call ions. The discovery of an electron. In the year 1987, a British physicist by name J.J. Thomson proposed that an atom constitutes of at least one negatively charged particle. He named it corpuscles, which was later called electron. So you can see electron was basically discovered by J.J. Thomson in the year 1897. E represents an electron. It means electron is denoted by small letter e, and it contributes to the negative charge of an atom. The absolute charge of an electron is a negative charge of 1.6 times 10 to the power minus 19 coulombs. The relative mass of an electron is 1 by 1836. Furthermore, the mass of an electron is basically 0. Discovery of proton. Proton was discovered by Rutherford when he conducted the famous gold foil experiment. In 1886, Goldstein discovered the presence of positively charged rays while experimenting with a discharged tube using perforated cathode. The rays were named anode rays or canal rays. A series of experiments led to the discovery of protons. Protons are the particles that contribute to the positive charge of the atom. Letter P represents proton. The absolute charge of proton is the positive charge of 1.6 times 10 to the power minus 19 coulomb. The mass of a proton is 1.6 times 10 to the power minus 19 gram and is considered 1, that is mass of a hydrogen atom. Discovery of neutron. The discovery of neutron didn't happen until the year 1932. James Chadwick discovered neutrons. He used scattered particles to calculate the mass of the neutral particle. The subatomic particle neutron is present in an atom's nucleus, and neutron is represented or denoted by small letter n. It is a neutral particle. The mass of neutron is 1.6 times 10 to the power minus 24 grams. Gram is not an appropriate unit for the calculation of such tiny subatomic particle, but Dalton or AMU, atomic mass unit, is the right unit for the calculation of tiny subatomic particles. Protons and neutrons have a mass of nearly 1 atomic mass unit. Atomic number. Elements are the building blocks for all the matter you see in the world. The question is, how can one distinguish these elements? The answer is simply by atomic number. Every element has a unique atomic number that helps to distinguish between elements. Let us study further to know the significance of atomic number. We have introduction to quantum numbers, which is followed by history of atomic number. We all know that in the periodic table, the elements are arranged in very informative order. The history of periodic table dates back to the late 1860s. In a time when Dmitri Mendeleev first discovered the periodic law. The periodic law soon became a major organizing concept of chemical sciences. But the law had some drawbacks. Some of the elements, when arranged according to Mendeleev's law, were out of sequence. It was not until Röntgen and his discovery of X-rays in 1895 that helped other scientists to further research on Mendeleev's discovery. English physicist H.G.J. Moseley in 1913 studied wavelength of X-rays emitted by different chemical elements. Moseley hypothesized the modern periodic table given by Mendeleev was on the basis of the number of protons in the nucleus of an atom. And this hypothesis forms the basis of atomic number. Each element has a unique number. This number represents the number of protons in the nucleus of an atom. The total number of protons present in the nucleus of every atom of a chemical element represents the atomic number of that element. Each element is characterized by a unique atomic number. It is represented by the letter Z. Atomic number is represented by the letter Z. As a matter of fact, every atom of an element consists of the same number of protons and so has the same atomic number, but different elements have different atomic numbers. For example, each atom of oxygen has 8 protons in its nucleus. So the atomic number of oxygen is 8. Similarly, the atomic number of carbon is 6. as all its atoms have 6 protons in its nucleus. We know that an atom consists of protons, neutrons, and electrons. Also, it does not have any net charge. Thus, it is electrically neutral. This means that the number of electrons is equal to the number of protons present in an atom. Therefore, atomic number Z is equal to number of protons and is also equal to number of electrons. Atomic numbers are whole numbers because it is the total number of protons, and protons are generally units of matter. As a matter of fact, it ranges from 1 to 118. It starts with hydrogen and ends with the heaviest known element, organism, OG. Theoretically, atomic numbers can be increased if more elements are discovered. However, with the addition of more number of protons and neutrons, the elements become prone to radioactive decay. Importance of atomic number. Atomic number helps in the identification of a particular element of an atom, forms the basis of the arrangement of the elements in the periodic table. The elements are arranged in order of increasing atomic numbers, helps in the determination of the properties of any element, but the valence electron determines the chemical bonding behavior of an element. Examples of atomic number. It does not matter how many neutrons and electrons are present in an atom. The Z, that is the atomic number, is always determined by the number of protons. For example, if an atom has 1 proton, then the atomic number is 1 and the element is hydrogen. Every iodine atom has 53 protons and the atomic number of iodine is 53. Cesium atom has 55 protons and hence the atomic number is 55. Atomic number of some of the elements are as follows: hydrogen 1, helium 1, lithium 3, hydrogen 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, and oxygen 8. How do we find atomic number? From the given information, we can find out the atomic number of an element in the following ways. 1. If we know the number of protons in an atom of an element, we can find out the atomic number because the number of protons is equal to the atomic number of the element. 2. If we know the element name or symbol, we can find the atomic number using the periodic table. For instance, say you want to know the atomic number of symbol Al, that is aluminum. For that, spot Al in the periodic table. You can see the atomic number of Al there. It is a positive whole number denoted by letter Z. For Al, it is 13. It is easy to find out the atomic number of an element using a periodic table because the elements are present in order of increasing atomic number. This is a structure of helium atom. You can see at the center you have positive, which denotes protons, and that is the helium, that is the atomic number of helium, and the electrons are 2. So you can see we have neutrons and then protons. Protons are 2 in this case. Electrons are also. Now the mass number of helium is the number of neutrons and protons. Mass number is the number of neutrons and protons. So if you look at the center nucleus, you will discover that we have 2 protons and 2 neutrons. And if you add up these 2, we are going to have 2 plus 2, which is going to give us 4. What this means is that the mass number of every element is simply the addition of the neutron number to the proton numbers. So we can see helium is 2 atomic. The subscript is the atomic number, while the superscript 4 is the mass number. A mass number is always denoted by the letter capital letter A. And lastly, if we know the isotope symbol of the element, we can find out the atomic number. There are many ways in which we can write the isotope symbol. For instance, carbon-14 or carbon-14-6 are 2 ways to write the isotope of carbon. Either way, we can find out the atomic number, as the isotope symbol will consist of the chemical symbol. The chemical symbol. To clarify, if given carbon-14, then we know that the symbol represents the carbon atom. So the atomic number is 6. If given carbon-14-6, then the atomic number will be the whole number, which is smaller of the 2 numbers. In this case, it is 6. Atomic number is usually the subscript of the element symbol.